So what's a confidence interval? The confidence interval is a range where we think a true parameter lies. Remember, for a parameter, we're talking about something from the population, so population mean or proportion. And a statistic means that it came from the sample, so a sample mean or a sample proportion. So a confidence interval will probably take the form of something like this. We take a sample statistic and we add and subtract the margin of error from it. So for proportion, it would look like something like this. The sample proportion minus the margin of error, and the sample proportion plus the margin of error. For a mean, it would look like something like this, where the margin of error depends on a few things. It depends on the standard deviation, the type of distribution, and the confidence level. Let's say we have a sample of test scores with a mean of 85 and that the margin of error for a 95% confidence level is 2. So the confidence interval would look like this. So we have a confidence interval of 83 to 87 for our sample mean of 85. So what does this mean? The 95% confidence level tells us that if we did the same process of going in, taking a sample, finding a sample mean and a sample standard deviation, 95 of those confidence intervals, if we did this 100 times, would have the true population mean of test scores. Because since we took a sample, we don't actually know what the true mean of the test scores were unless we ask everyone who took the test. So this is a way for us just to have that confidence that the sample mean that we got probably, hopefully, contains the true population mean, and we could say that with 95% confidence. We can't say that there's a 95% probability that the true mean of test scores lies between 83 and 87, because it's not a probability. It's more of a confidence in the process itself. We know that by constructing a confidence level with 95% confidence, that if we did the same thing 100 times, 95 of those confidence intervals that we took would have the true population mean, because we have to account for just regular random error, which isn't our fault. It's like the Kobe Bryant problem. We know that even if he has a mean points per game for every season of maybe 26 points, we can't expect him to actually always get 26 each time. It's going to vary just naturally. And that's what the confidence interval does for us.